Chemical properties of metals and nonmetals. Here we are going to discuss reaction of metals and nonmetals with oxygen. Rusting of iron. You all know when iron is exposed to atmosphere, it reacts with oxygen and water and hence rust is formed. To test the nature of rust, you need a test tube, rust suspension, a small spoon, some water and hence blue and red litmus paper. Take a spoonful of rust and add in small amount of water taken in the test tube. You can see it forms a suspension. So shake the test tube very well to dissolve it. Then you have to take blue and red litmus paper to test the nature of rust. You can see red litmus paper turns blue and blue litmus paper remains the same. From this we can understand that iron reacts with water and oxygen and form hydrated iron oxide, which is basic in nature. Burning of magnesium ribbon. Magnesium reacts with oxygen and form magnesium oxide. Now we can watch a small activity.
Today I am going to show you the demonstration of a chemical reaction, that is burning of magnesium. So here I have a strip of magnesium which is cut from the magnesium ribbon. So this is the magnesium ribbon and this is Bunsen's burner and a watch glass in which I am going to collect the magnesium oxide, which is white in color. These are the pair of tongs. So when magnesium reacts with oxygen, it requires heat energy, and after initiating this reaction you will see that the magnesium burns in presence of oxygen to form magnesium oxide, and magnesium burns in oxygen with a brilliant white flame, that is called a dazzling white flame. Very difficult to see that. So let's try the experiment, and here I am going to hold this magnesium ribbon. Actually we don't require a very big piece of magnesium. It's very handy, you can even break it with your own hands. So I choose to put all other things aside. As you can see that magnesium burns with a dazzling white flame. Now as the reaction is completed, you can see that this white color thing is being produced. This white color is nothing but magnesium oxide. Even let's try to break it. This is white color powder. This white color powder is nothing but magnesium oxide. So as you saw that magnesium burns with dazzling white flame.
Here magnesium reacts with oxygen and form magnesium oxide. The ash obtained on burning of magnesium ribbon can be dissolved in water and tested for acidic or basic nature. It turns red litmus paper into blue. That means it has basic nature. Greenish coating on copper. When copper is exposed to atmosphere, it reacts with moist air and forms a dull green coating on its surface. The green material is a mixture of copper hydroxide and copper carbonate. This also we can test with red litmus paper. We can see that red litmus paper turns to blue in color. From all these activities, we can understand that metal oxides are basic in nature. Reaction of nonmetals with oxygen. We can see the burning of sulfur.
Burning sulfur in pure oxygen. This is what sulfur looks like. Sulfur is a bright yellow powder. And in this gas jar here, I have oxygen. Oxygen is a colorless, clear gas. What I'm going to do is take some sulfur in on a combustion spoon here. You can see what a combustion spoon looks like. This thing here acts as a shield, shielding me from any sparks that might fly up. And at the same time, once I put this combustion spoon into the gas jar, here's an empty gas jar, once I put it into the gas jar like so, it seals the contents inside. So remember here I've got a gas jar of pure oxygen. The air is 1/5 oxygen, 4/5 nitrogen. Anything that burns in air will always burn even better in pure oxygen. So what I'm going to do is to take a little bit of this yellow powder here on the combustion spoon, not too much. I'm about to reduce a very poisonous gas, sulfur dioxide, formula SO2. Even small amounts of this gas that I'm about to produce can bring on attacks of asthma, usually a few hours after exposure to the gas. Now here I've got my Bunsen flame. I'm going to put it to a blue flame, non-luminous flame, and I'm going to melt the sulfur. So let's see if we can pick this up in detail. The sulfur begins to melt right away, and you can see on the surface it's already beginning to turn a ruby red colour. So I continue to melt the sulfur. Doesn't take much heat, there's it all melted, and that yellow powder is turned into a red coloured liquid. I now ignite the vapour. It's now beginning to vaporise. I ignite the vapour and I lower it into the gas jar of pure oxygen, and there you see a beautiful blue flame. Do I have some UI indicator paper there? Yeah. And it's producing a choking gas, sulfur dioxide, so I'm going to put this into the fume cupboard right away. Let me just check first of all the pH of the solution. If I wet some indicator paper, some universal indicator paper, let me put that universal indicator paper which you see there into the gas jar, and there you see that it's turned red, indicating that we have formed an acidic gas. Sulfur dioxide is an acidic gas.
When sulfur dioxide is dissolved in water, sulfurous acid is formed. It turns blue litmus paper to red color. That shows acidic nature. Generally, oxides of nonmetals are acidic in nature.